How can we update the Q values in Q learning? Or what is the idea of Q table? The idea is quite simple. We will look at a grid. If you have a grid like this, and we have the state number. For example, if this is state number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, this is the state number, and in each state number it has some immediate reward. For example, if we have minus 20 here and 100 at the end of the root, our agent, for example, if our agent start here, of course, I think you can see that from state 5, there are two operations that you can apply. That is go up or right. So you will have the state Q table of state 5 and up, and Q of state 5 and right. Okay. So this is the values that you can fill in by the learning algorithm. Okay. So if you are at state 1, you have two operations, that is go down and go right. For state 2, you can go left, you can go down, you can go right. If you are at state 6, you can go left, you can go up, you can go right. If you are at state 3, you can go left, you can go down, you can go right. If you are at state 7, you can go left, you can go up, you can go right. If you are at state 4, you can go left, you can go down. If you are at state 8, you can go left, you can go up. So this is the operations that you can have in each state. Okay? So and the idea is simple. If you have a queue of Q values of state S and action A, it will be updated by this equation. Is the original QS with action A plus learning rate alpha times rewards. This is the immediate rewards. If you go to, because you are at state S and take action A, right? So you will go to S prime. This is the next state. Plus gamma of max of, you are at S prime. Of course, S prime has all actions in S prime. Which action give the highest Q values? Sorry, max of Q of S prime and A prime. Okay, and then minus Q of S and A. Okay, so this is the equation. So you can see that if we move alpha inside, and of course you can see this term QSA minus alpha QSA plus alpha rewards S prime gamma of max A prime of Q of S prime A prime. You have 2 times alpha here. So this term is, you can write is 1 minus alpha q of S and A plus alpha reward S prime plus alpha gamma max A prime of Q S prime A prime. Okay, can you see? Yeah, we have an equation that you can see that from the previous S and A, you have to times it by 1 minus alpha Q of S and A. What does it mean? It means that if your alpha is, for example, 0.8, this one will be 0.2. It means that from the previous QSA, it will be like reduced to 20% of the previous QSA. Okay, so this is the values that you can control, that how the Q will be remain in the next state. Okay. Okay, so once we have the equations, now we will, I'll show you uh, how can we update the values and how can we work. For example, if I initialize all q of S and A to be 1, q of 5 up is 1 q of 5, right is 1 q of all q's, q of down is 1 q of 1, and action right is 1. All of them are 1. At first agent is at state 5. As you can see here, agent is here. So if you random and your agent go up, so now your agents go up. Oh, sorry. Oh, sorry. Your agent go up right here. So the values of q of 5 up is original q of 5 up, that is 1, plus in this case if we give alpha to be 0.5, that is reduced and half of the previous one, so it is 0.5. We use this original one. Immediate reward as S prime. In this case, S prime is state 1, right? Because we go up to state 1. So S prime is 1. Now, it will be 0. Because in state 1, we have no immediate reward. So it is 0. Plus, if we give gamma to be 0.8, so this one will be 0.8, and maximum of q of S prime A prime. Now we are at state 1, so maximum of q of A. So you have two action, go right and go down, that all of them are 1, right? So because I'm sorry that I will, oh, I won't. Okay, I will write here, change the color to make it, yeah, uh, this one. So this one is everything 1 1 1 1 1 1 1 1 1 1 1 1 1 and 1 1 and 1 1 and 1 and 1 and 1. So you can see that now max of q here, yes, of course, everything is 1, so this is 1 minus original q5 up is 1. So it will be 1 plus 0 0.5, 0 plus 0.8 minus 1. So this is minus 0 0.2. So it will be 0.1, right? Okay, so this is 0.9. So 5 up will be changed to 0.9. So these values will be updated to be 0.9. And agent is at cell 1. Okay. So next. If I move the agent to the right, how can we update the Q values? If we move to the right, what happened? Look at this. We are at here, right? Agent is here, move to the right. The original or the previous Q of one action right, the Q value is 1. So we will update the values right here. Q of 1 and right is, the original is 1 plus 0 0.5 immediate reward. You go to state 2, right? You go to state 2. From state 1, go right to state 2. So no immediate reward. It will be 0 plus 0 0.8 and max of here at state 2, max of Q is 1, right? Because all of them are 1. So it is 1 again. Minus the original is 1. So it will be same. So it is 0.9. So we will update these values to be, look at this, 0.9. Okay. And then now the agent is at state 2. Yes. The agent move here. So guys, now we are at state 2 and I would like to show you the effect of immediate reward. So I move this agent to the right. In your real world, maybe it's like the random one. So maybe you may not face state number 3, but in this case, I will move it to state number 3. So look at this. We are at state 2 and action is right. So the previous one is 1, right? This one is 1. So 1 plus 0 0.5. Immediate reward in this case is minus 20. Don't forget that reward of S prime. S prime is, yes, you move to 3. So in this case, S prime is 3. So this is minus 20. Plus gamma is 0 0.8. Max of Q at state 3 of them are still 1. Minus the original one is 1. The previous one is 1. So it is 1 plus 0 0.5. This is minus 0 0.2. So it is, okay. So 1 plus 1 minus 10.1. So this is minus 9.1. Okay. Okay, so it is minus 9.1. So look at this. Look at this. It will change this Q into minus 9.1. That tells us that if you are at state 2 and if you go right, this is the state, the values that is maybe it's not good because this is minus 9.1. Okay, so but we didn't finish it yet, so we have to move agent. Now our agent is here, move to the right. Okay, so if you move to the right again, if you are at state 3 and you want to move to the right to state 4, here, move to state 4. Sorry. If you move to the right to state 4, in state 4, all of action is go left and down. All of them are 1. So I think you can guess. You can guess we will get the same thing as the previous one. That is, it is 0.9. Oh, sorry. Here. (0.9). And now our agent will move to state number 4. And finally, if our agent move down from state 4, this one, yes. So let's take a look at the reward. So we are at, look at this. We are at state number 4. We calculate Q3 right, same as other, so it will be 0.9. So if we are at state 4 and we go down, so the original one is 1 plus 0.5 times immediate reward, that is 100, because we are at state 8 right now, right? Plus 0.8 times the maximum of 8, so it will be 1 minus 1. So it is 1 plus 0.5 and 100 minus 0.2. So it is 1 plus 99.8. So it is 1 plus 49.9. That is 50.9. So the values here will be 50.9. How different? How different? 50.9. Can you see? At this point, we have the Q values from state 2 to 3, that is minus 9.5. That is, we should avoid this operation, and we should use we should use this operation from state 4 go down. This is a good one. This is the bad one. Okay, so this is the first iteration. Once you finish something, now you can move your agent. You can move your agent sorry, back to the original one, and then we will work with the data, the Q table again. I will I will copy this one to the new place to show you that how can we update the values. I think this is quite long videos, so I will cut it and go to the new videos, go to the new video clips. Okay, so we are at this state, and you can take a rest, and then we will come back with the next iteration.